Hello students, in this video we are going to do the back exercise of chapter 9, Force and Laws of Motion. Okay, so I'll read the first question. An object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the conditions that must be placed on the magnitude and direction of the velocity. If no, provide a reason. Okay, so you should first read the question properly, understand it, and then try to give the answer to it. It is written here, an object experiences a net external unbalanced force. Net zero external unbalanced force, which means that there is no force acting on an object. Maybe there are many forces acting, but there is no net force acting on an object. That means F is 0. They have asked further, is it possible for the object to be traveling with a non-zero velocity? Non-zero velocity means it should be moving. So is it possible that if no external force is acting on a body, can it move? If yes, state the condition that must be placed on the magnitude and direction of the velocity. If no, provide a reason. So here, first of all, answer is yes. It means if no force is acting on the body, or if net zero external unbalanced force is acting on a body, which indirectly means F is 0, can a body move? Can a body have non-zero velocity? Yes. Okay. If yes, you have to state the conditions on the which should be valid for the magnitude and direction of the velocity. So I have here written all the conditions, but let us try to understand how I have got these conditions. Now conditions: speed of the object should be constant, direction of motion should not change. It means, in other words, the body should be moving with uniform speed. Constant speed means uniform speed, and without changing direction means in a straight line. So in other words, we can say that the body should be moving with uniform speed in a straight line. But how they have asked the question? They have asked us what will happen to the magnitude, what will be the condition of magnitude and direction of velocity. Here, indirectly this means that magnitude and direction of velocity should not change. Okay, so I have proved these conditions here mathematically also. No need to write it in the answer, but this is just for your understanding. See, if F is 0, according to Newton's second law of motion, F is equal to ma is equal to 0, where m is mass of the body and a is acceleration produced in the body. We know m is always positive, it can never be 0. So a is 0. And it implies a is 0. What is a? V minus u upon t, acceleration. So if v minus u upon t is 0, we know that v minus u is 0, because 0 into t will be 0 when you take t on the other side. So which implies further that v is equal to u. So from this it is clearly understood that if F is 0, if no external unbalanced force is acting on the body, then v is equal to u. Remember, what is this? This indirectly, what I am doing is, I am trying to prove Newton's first law of motion from Newton's second law of motion. This question I will be doing afterwards. But here indirectly what we have done, if F is 0, V is u, it means the body will maintain the same velocity. If u is 0, V will remain 0 only. It means if the body is at rest, the body will remain at rest if no force is acting on the body. But here the question is not of rest. Here the question is, if F is 0, can the body move? So we will not consider that u is equal to 0 case. We will consider that u is having certain value and v value will remain the same. It means the body will continue to move with the same velocity u. V will be equal to u. Same velocity u means magnitude and direction of velocity will remain the same. So here mathematically I have proved, and conditions we can write it this way. So what is velocity? It is nothing but speed of a body in a given direction. So speed of the body should be constant, direction of motion should not change, it means it should remain the same, or indirectly we can say that the body should be moving with uniform speed in a straight line. Okay, and finally this is possible. These first two conditions are more important because already in the question it is mentioned if f is 0. But we know if the body ultimately stops, why it stops? Because of this third and fourth reason. Air resistance should be 0. If air resistance is there, if air is opposing the motion of the body, then also forces acting, opposing forces acting on the body, and the body stops. Fourth point is opposing force, one more opposing force is there, that is frictional force, which acts between the object and the ground. It acts on the object, okay, and so it is acting between the object and the ground or surface on which the body is moving. This force should also be 0, then only F can be 0. So actually in your answer these first two conditions should be mentioned. Third and fourth condition I have written when F is not 0, when this third, fourth conditions are not strictly positively there. Okay. So I hope the answer is clear to you. Okay. This is just for understanding. You can just write the first and second condition here. Now the second question is, when a carpet is beaten with a stick, dust comes out of it. Explain. If you have watched the earlier videos of this chapter, I hope you must be knowing the answer. It should be on your tips because this question is similar to the question that we have discussed before. When we shake the branch of a tree, some of the leaves or fruits may fall down. It is just similar to, answer is similar on it as that question. So when a carpet is beaten with a stick, dust comes out of it. Explain. Here we will say that when we beat the carpet with a stick, carpet comes into motion, but dust particles remain at rest due to inertia of rest, and finally we can say due to gravity they fall down, and hence the carpet also gets cleaned. So basically due to inertia of rest, these words should not be missed from the answer. Complete explanation is required with these words due to inertia of rest. I hope this is clear to you. Now the third question, it is not a numerical. Why is it advised to tie any luggage kept on the roof of a bus with a rope? Why is it advised to tie any luggage kept on the roof of a bus with a rope? I am sure you must be knowing answer to this question also. If you remember when I had explained inertia in one of the videos, I have explained you one example where a person sitting in a vehicle gets forward, backward or sideward jerk depending upon the different situations. Okay, so same reasoning we can give it here. So if we don't tie luggage kept on the roof of a bus with a rope, what will happen? If the bus is moving and brakes are applied and it suddenly stops, we know that luggage will try to maintain its state of uniform motion, so it may get a forward jerk, it may fall forward due to inertia of motion. On the other hand, if suppose when the bus is in motion, then due to inertia of motion, the luggage may fall forward when the brakes are applied. And on the other hand, if suppose bus is at rest and all of a sudden the driver starts the bus and accelerates it, then the luggage which is kept on the back side of the bus roof, but on the back side, okay, so in that case, due to inertia of rest, luggage will try to maintain its state of rest and luggage may fall backward on the back side of the bus. This is due to inertia of rest. And also when the bus takes a turn due to inertia of motion, we know the luggage may fall on any side of the bus depending upon the direction in which the bus is taking the turn. This is due to inertia of direction. So in short we can say Due to inertia, luggage kept on the roof of a bus may fall, okay, if it is not tied with a rope. So it is advised to tie any luggage kept on the roof of a bus with a rope. I hope this is clear to you. Now, the fourth question is, a batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. Okay, so a batsman hits a cricket ball which rolls on the level ground first, and then after covering a short distance, it comes to rest. The ball comes to a stop. The ball rests. Why? Because now there are four options given in the question and you have to select any one. So the ball stops after covering some distance on the ground because you have to choose one of these four options. A is the batsman did not hit the ball hard enough. Do you think it is right? No. Because even if the batsman did not hit the ball hard enough, then the ball is very small. It will move, but it is going to move, and it should not stop because of this. It should continue to move with its slow speed then. Secondly, B. Velocity is proportional to force exerted on the ball. This is again similar to the first point. Okay, because the force exerted on the ball, they have considered here, if it is small, then velocity is proportional to force, means velocity will be small. But again we know that even with small velocity, the ball should not stop. It should continue to move with the same small velocity. So these 2 points are quite similar. Okay. Here they have written that the force is less, did not hit the ball hard enough, means force applied is less. And here they have written velocity is proportional to force, it means less force and hence less velocity. But again, from these 2 points we cannot say these are the reasons why ball has stopped. Third, there is a force on the ball opposing the motion. Yes, this is correct. Let us see first the fourth one. D. There is no unbalanced force on the ball, so the ball would want to come to rest. Remember Newton's first law of motion? Here, even if no unbalanced force is acting on the body, now we have done in the first question also, today also, if no unbalanced force is acting on the body, if F is 0, V should be equal to U. It means if the ball is moving, it should continue to move with the same velocity. Okay, so here this is also wrong. C is the correct option. There is a force on the ball opposing its motion and hence the ball stops. And I think so you must be knowing the answer that these opposing forces can be due to air resistance. Air may try to stop the motion of a ball, and secondly, frictional force between the ball surface and the ground on which ball is rolling. So these two forces are the opposing forces which oppose the motion of the ball and hence the ball stops. Now the fifth question is a numerical. So listen to it carefully. A truck starts from rest and rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 metric tons. Okay, and in the bracket they have given in the question, or even if it is not given, we know that 7 metric ton is the mass, and you should remember that 1 metric ton is 1000 kg. So even if it is not given in the question, you should remember. Okay, so let me read it once again. A truck starts from rest. So given initial velocity u is 0 meter per second as the truck is initially at rest. It rolls down a hill with a constant acceleration. It means motion of the truck is uniformly accelerated because acceleration is constant. It travels a distance of 400 meter in 20 seconds. So 400 meter is distance, so it is S, and time taken is T is 20 seconds. Find its acceleration A. Okay. Find the force acting on it, F. We have to find out A and F. If its mass, M, is given as 7 metric tons. And I have told you 1 metric ton, or sometimes they don't write metric. They simply write 7 tons. Okay, then also the same conversion. So 7 metric tons is 7 into 1000 kg, and that is 7000 kg. Now, let us see how to, any conversion required first of all, only for mass, that we have done. Rest is in SI units only. Okay. Now, we have to find first acceleration. So, to find acceleration, we know that this is a uniformly accelerated motion. We can use any of the 3 equations of motion. U, S, T are there. So, we can use the second equation of motion, that is S is ut plus half at square. Students, remember, although these equations are given in the first chapter, but they can be used in any chapter. They should be on your tips. Okay. So, S is ut plus half at square. So, just putting the values, S we have 400, U is 0 into T 20 plus half a T square. Students generally forget to write 20 into 20. Many students I have seen, they do the mistake, they just put the value once only. So, take care there. 400 is equal to 0 into 20 is 0 plus, after doing simplification, you get this right hand side as 200A, and small a comes out to be 2 meter per second square. So, acceleration, first part we have done. Acceleration is 2 meter per second square. Also students, you should know the units of all the physical quantities, because if you write only 2, again you are going to lose marks there. Or if you don't write unit, or you write wrong unit, then also your marks will be lost. Now next is F. Now we can use Newton's second law of motion. The same formula, F is ma. Mass is now known 7000 kg and acceleration is 2 meter per second square. So F is 7000 into 2, that is 14,000 Newton. Either you write the complete spelling, but then it should start with a small letter N-E-W-T-O-N, Newton, or you write the symbol capital N. This was quite a simple numerical. I hope it is clear to you. Sixth question is, a stone of 1 kg is thrown with a velocity of 20 meter per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? So, I'll read it again. A stone of 1 kg is thrown with a velocity of 20 meter per second. So, given mass of the stone m is 1 kg and it is thrown with a velocity of 20 meter per second. So, initial velocity u is 20 meter per second. Then it comes to a rest after traveling a distance of 50 meter. So, distance traveled is 50 meter, and as it comes to rest after traveling this distance, so v at the end is 0 meter per second. What is the force of friction between the stone and the ice? You have to find the force. Which force? Which is acting on the stone. Which is that? Frictional force. You have to find it. Okay? Frictional force acting on the stone. We know that F is equal to ma. Again, here only frictional force is acting, and it is a case of uniformly accelerated motion only. No other force is acting on it. One constant force is acting, and so constant acceleration is there. F is ma. M is given, but A we do not have, and if we use the formula A is V minus U upon T, T is not there, so we cannot find A by using that formula. Again, for finding A, we can use any of the 3 equations of motion. Now we should use the equation where T is not involved, as it is not given. So we'll use the third equation of motion. V square is U square plus 2AS. Putting the values of V, U, A we have to find out, NS, we get 0 is equal to 400 plus 100A. So taking 400 on the other side, we can get 100A is equal to minus 400. So we can calculate value of A to be equal to minus 4 meter per second square. Acceleration is negative, so it is a case of retardation, and we can easily, that was quite obvious because the ball stops ultimately. So it is a retarding case. Now let us find the force. Force F is MA. M we have 1 kg, A we have found minus 4 meter per second square. So we get the final answer for F as minus 4 Newton. Okay, so you should know the correct unit, and you should also not omit this negative sign. Negative sign you have to take here. And since whenever the answer is negative, you should mention a sentence about it. Why the force is negative? Because it is a frictional force, opposing force or retarding force acting on the stone. So I hope the video is clear to you and you have learned how to write answers to the questions which are based on Newton's first law of motion or inertia and which are based on Newton's second law of motion. We'll continue with the back exercise in our next video. Thank you, students.